Hey there, space enthusiasts. Have you ever looked up at the night sky and wondered why space is so dark, yet we have light on Earth? It's one of those mind-boggling questions that makes you think deeply about our universe. Today, we're diving into this cosmic mystery to understand what makes the vast expanse of space so dark and why our planet is bathed in sunlight every day. Stick around, you're about to get some stellar answers. To understand why space is dark, we need to first grasp how light works. Light travels in straight lines and requires a medium to reflect off of in order to be seen clearly. On Earth, light from the sun scatters in our atmosphere, making everything around us bright and visible. In contrast, space is a vacuum, with almost no particles for light to bounce off, making it appear dark even when sunlight is present. You might wonder, if the sun is so powerful, why doesn't it light up space? The answer lies in the absence of a medium to scatter the light. On Earth, air molecules scatter sunlight, giving us the bright blue sky. Without an atmosphere, there's nothing to disperse the light in space. Even though space is filled with stars emitting light, that light travels in straight lines and doesn't illuminate the space around it. Another reason space appears dark is how our eyes perceive light. Our eyes are designed to see scattered and reflected light. In space, the lack of scattering means we can only see light sources like stars or the sun directly. The vast darkness between celestial bodies remains invisible to us, not because there is no light, but because our eyes can't detect it in the vacuum of space. Earth's atmosphere plays a crucial role in making our world bright and colorful. When sunlight enters the atmosphere, it collides with air molecules, dust, and water vapor, scattering in all directions. This is why the sky appears blue during the day, and why we can see the landscape clearly. Without this scattering, Earth would look as dark as space even during the daytime, except for the bright disk of the sun. Now let's touch on an interesting concept called Olber's paradox. If the universe is filled with infinite stars, why isn't the night sky completely bright? The solution lies in the vastness of space and the finite speed of light. Light from many distant stars hasn't reached us yet, and some stars are too far for their light to be seen. Combined with the universe's expansion, this explains why the sky remains dark despite the presence of countless stars. While space appears dark to our eyes, it's not completely devoid of light. If we could see all wavelengths of light, such as infrared and ultraviolet, space would actually be glowing. Instruments like the Hubble Space Telescope can detect these invisible wavelengths, revealing a universe brimming with light we can't see with the naked eye. Space also contains cosmic microwave background radiation, a faint glow left over from the Big Bang. Although it's invisible to the human eye, it's detectable with specialized instruments. This radiation fills the universe, but because it's so weak and in the microwave spectrum, it contributes to space's overall dark appearance. Another reason space seems dark is due to the vast distances between celestial bodies. Light from stars diminishes over long distances, making even nearby stars appear as faint points of light. This fading effect contributes to the overall darkness of space. Interstellar dust and gas can absorb light from distant stars. While it's not enough to fully block light, it dims and scatters it, contributing to space's darkness. This absorption is more noticeable in denser regions of space, like nebulae, where light is partially blocked. When you look at the night sky, you see stars as bright points of light against a dark background. This contrast occurs because there's no medium in space to reflect or scatter starlight, making the area around stars remain pitch black while the stars themselves shine brightly. Even though the sun's light floods our solar system, space still looks dark. This is because sunlight travels in straight lines, and without particles to reflect or scatter it, the surrounding void appears dark. However, when sunlight hits objects like planets or spacecraft, they become brightly illuminated. On Earth, our atmosphere is a game changer. Sunlight scatters in all directions, thanks to molecules in the air. This scattering makes the sky appear blue and bright during the day, creating a stark contrast to the inky blackness of space. Astronauts in space often experience a strange phenomenon. Their surroundings are dark, but the sun-facing parts of their suits and equipment are incredibly bright. This happens because there's no atmosphere to diffuse light, so sunlight directly illuminates objects while everything else remains in shadow. Space is a near-perfect vacuum with almost no particles to reflect or scatter light. This lack of matter means that light can only be seen when it directly hits an object or when looking directly at its source, like a star. While not directly linked to why space is dark, Earth's magnetic field plays a part in protecting our atmosphere. This shield helps maintain our air, allowing for the scattering of light and making Earth's sky bright and vibrant. Without this protection, our planet might resemble the dark skies of space. Designing spacecraft involves dealing with the darkness of space. Engineers must ensure that spacecraft are equipped with powerful lighting systems because the lack of atmospheric scattering means light sources must be carefully placed and controlled to illuminate key areas. Not all planets have atmospheres capable of scattering light like Earth. For example, the Moon has no atmosphere, so its sky remains dark even during the day. On Mars, the thin atmosphere scatters light differently, giving the sky a reddish hue rather than bright blue. There's a difference between interstellar space, between stars within a galaxy, and intergalactic space. Between galaxies, both regions are dark, but intergalactic space is even more desolate and lacks the faint light from nearby stars, making it seem even darker than interstellar space. Gravitational lensing occurs when massive objects, like galaxies, bend light around them. This bending can brighten distant objects by focusing their light, but it also highlights how vast and dark the space between galaxies truly is. Nighttime on Earth offers a glimpse into space's darkness. When the sun sets, the absence of scattered sunlight reveals the true darkness of the universe. The stars become more visible, but the vast emptiness between them is a reminder of space's void. Light pollution on Earth can obscure our view of space's darkness. In urban areas, artificial light scatters in the atmosphere, washing out the night sky. In remote areas, however, the absence of light pollution allows the sky to reveal its true dark nature, similar to what astronauts see from space. The Moon doesn't generate its own light, but reflects sunlight. During a full moon, this reflected light can brighten Earth's night sky. But in space, the vast areas around the Moon remain dark due to the lack of atmosphere to reflect this light further. In space, shadows are much sharper and darker than on Earth. Without an atmosphere to diffuse light, objects cast stark, well-defined shadows. This contrast adds to the perception of space being extremely dark when illuminated objects are surrounded by deep shadows. As humanity explores space further, understanding the behavior of light in a vacuum will be essential. Technologies like artificial light scattering or reflective materials could one day make space stations and habitats feel less isolated in the vast darkness of space. Space's darkness has inspired philosophical thought for centuries. It symbolizes the unknown and the infinite, reminding us how small we are in the grand cosmos. This darkness fuels human curiosity and our desire to explore beyond the stars. Nebulae are vast clouds of gas and dust in space that can reflect and emit light, making them some of the brightest objects in the night sky. However, the light they produce is often localized, meaning the surrounding space remains dark. These glowing regions offer brief glimpses of light amid the vast darkness, but they don't illuminate space the way our atmosphere lights up Earth. Black holes are another factor in space's darkness. These gravitational giants trap everything, including light. When light gets too close to a black hole, it's pulled in and never escapes. This absorption of light creates regions of complete darkness, adding to the overall void-like appearance of space. The universe is measured in light years, meaning distances are so vast that light from distant stars can take millions or even billions of years to reach us. This delay contributes to space's darkness because we can't yet see the light from countless stars that are too far away. In space, Planets and moons reflect sunlight, which is why we can see them from Earth. However, their reflected light only reaches a small area around them. This localized illumination doesn't spread out like light on Earth, leaving the vast majority of space untouched by this reflection. It's fascinating how the sun, our solar system's most powerful light source, doesn't brighten the entirety of space. Its light travels in a straight line and only illuminates objects directly in its path. The absence of an atmosphere or medium in space leaves most areas between celestial bodies pitch black. The universe is constantly expanding, stretching light waves over time. This phenomenon, known as redshift, causes light from distant galaxies to become less visible. As the light stretches, it shifts to longer wavelengths, making it harder to detect with the naked eye and contributing to the overall darkness of space. Space telescopes like Hubble and James Webb help reveal the hidden light in space. These instruments are designed to detect wavelengths invisible to us, such as infrared and ultraviolet. Their discoveries show that while space seems dark to human eyes, it's actually filled with light in various forms beyond our visual spectrum. Air pressure on Earth helps distribute light evenly across the sky. In space, the absence of air pressure means light doesn't spread or scatter, further deepening the perception of darkness. This absence of pressure makes objects in space appear starkly illuminated against a black backdrop. Stars emit immense amounts of light, but due to the vast distances between them, their light often doesn't overlap enough to illuminate space. Even in star-rich regions like the Milky Way, space remains predominantly dark because the light from individual stars isn't scattered or reflected. Albedo refers to how much light an object reflects. Planets with high albedo, like Venus, appear bright because they reflect a significant amount of sunlight. However, this reflected light doesn't brighten space itself, only the object reflecting it, which is why space around high albedo planets remains dark. On Earth, our atmosphere scatters sunlight into various colors, giving us blue skies and vibrant sunsets. In space, there's no atmosphere to create this effect, so no matter how bright a star or planet appears, the surrounding space remains devoid of color and light. Between galaxies lies a vast emptiness known as intergalactic space. This region is even darker than areas within galaxies because it's devoid of stars, dust, and gas. With no nearby light sources, intergalactic space represents one of the darkest areas in the universe. Astronauts aboard the International Space Station, ISS, experience both darkness and light. When in direct sunlight, the station is intensely bright, but as it orbits into Earth's shadow, complete darkness takes over. This alternating cycle of light and dark highlights how dependent light perception is on direct exposure to a light source. While auroras are an Earth-based phenomenon, they show how light interacts with space. Solar particles colliding with Earth's atmosphere create brilliant light displays. However, beyond the upper atmosphere, where these particles interact, space remains dark due to the lack of a medium to continue scattering the light. Comets become bright when they pass close to the sun, emitting tails of gas and dust that reflect sunlight. Yet, despite their brightness, the space are the most mysterious corners of the cosmos. Capturing images in space presents unique challenges due to the absence of atmospheric light diffusion. Photographers and space agencies use advanced cameras with high sensitivity to light to capture distant stars, planets, and galaxies. Without these technologies, much of space would remain visually inaccessible. However, even with sophisticated equipment, the darkness of space persists in the background, emphasizing the isolation of celestial objects. Astronauts often report that the darkness of space can be both awe-inspiring and unsettling. The deep black void emphasizes the vastness of the universe and the fragility of human existence. This psychological impact is carefully managed during long space missions to maintain mental well-being, showcasing how profound the darkness of space can be on the human mind. While the night on Earth gives us a glimpse of space's darkness, it's not the same. On Earth, Even during the darkest night, there's often ambient light from the moon, stars, or artificial sources. In space, however, there's an absolute absence of ambient light unless directly illuminated by a star, making the darkness far more complete and absolute. Light travels at a finite speed, 186,000 miles per second. This means that light from distant stars and galaxies takes time to reach us. The farther away an object is, the longer its light takes to arrive. Because of this delay, much of the universe remains visually inaccessible, contributing to the overall darkness of space as we perceive it. Infrared technology allows astronomers to detect heat emitted by objects in space, even when they appear dark to the human eye. This helps scientists study celestial bodies hidden in darkness, like cool stars, planets, and distant galaxies. Infrared imaging reveals that space, though dark invisible light, is alive with energy in other spectrums. Space and time are intricately connected. When we look at distant stars, we're essentially looking back in time because their light has traveled for millions or even billions of years to reach us. This time delay means that much of the light in space hasn't reached us yet, creating an impression of vast darkness even in star-filled regions. On Earth, light diffuses through particles in the air, giving us soft, even lighting. In space, the vacuum prevents this diffusion, so light stays concentrated in straight beams. This lack of diffusion results in sharp contrasts between illuminated and dark areas, making space appear more intensely black than anything we experience on Earth. Even though space appears dark, it's filled with invisible light forms like gamma rays, X-rays, and radio waves. These types of energy can't be seen with the naked eye, but are constantly traveling through the universe. Instruments designed to detect these wavelengths reveal a cosmos filled with dynamic energy hidden behind the veil of darkness. The interstellar medium, made up of gas and dust, plays a role in filtering light as it travels through space. While this medium is incredibly sparse compared to Earth's atmosphere, it still absorbs and scatters light over vast distances. This filtering effect contributes to the dimming of starlight and reinforces the perception of darkness in the cosmos. Astronauts' spacesuits are designed to protect against the extreme conditions of space, where light and darkness can be intensely contrasted. The suits are equipped with visors that shield their eyes from the sun's intense glare, while still allowing them to see clearly in the surrounding darkness. This balance ensures safety and visibility in an environment where light is either overwhelmingly bright or completely absent. In deep space, far from any star, there's no light source to break the eternal night. This region of space is perpetually dark, making it one of the most desolate and mysterious parts of the universe. Without stars to illuminate the surroundings, these areas remain shrouded in complete blackness, challenging humanity's understanding of light and existence. Dark matter is an invisible substance that makes up a significant portion of the universe. Although it doesn't emit or reflect light, it exerts gravitational influence on visible matter. While it doesn't contribute to the visible darkness of space, its presence highlights how much of the universe is hidden from direct observation, adding to the overall sense of cosmic mystery. Star clusters, like the Pleiades, appear bright in contrast to the dark backdrop of space because their light isn't scattered. These dense groups of stars shine brightly in localized areas, creating striking visuals against the surrounding void. However, beyond their immediate vicinity, space remains dark, emphasizing their brilliance. Gravity influences how light travels through space. Massive objects, like black holes and galaxies, bend light through a phenomenon known as gravitational lensing. Welcome to Blessovia Science TV, where we take you on an exhilarating journey through the cosmos and unravel the mysteries of science. We are excited to offer you the opportunity to become a valued member of our ever-growing community of cosmic enthusiasts and knowledge seekers. Exclusive access to cosmic content. As a member of Blessovia Science TV, you will gain exclusive access to a treasure trove of cosmic content, including documentaries, interviews with leading scientists, space missions updates, and awe-inspiring visualizations of the universe, live Q, and as sessions with experts. Your membership will grant you the chance to participate in live Q and A sessions with renowned scientists, astronomers, and space explorers. Get your burning questions answered by those who push the boundaries of human knowledge. Embark on a journey that spans the cosmos and join us in unraveling the secrets of the universe. Become a Blesovia Science TV member today, and together we will reach for the stars. Thanks for watching. Subscribe, like, and share. Don't forget to leave your comment.